Torsional frequency of two disk system means a shaft which is having two disks attached to it, and we need to find out torsional natural frequency using the standard formula. The standard formula to be used for calculating torsional natural frequency having two disk system. Using this formula, first torsional natural frequency is calculated only. For higher modes of frequency, Holger methods to be used. Two parameters are required for this formula. One parameter is called mass moment of inertia of disk, and another parameter is torsional stiffness of the shaft. So we need to calculate mass moment of inertia of disk and torsional stiffness of the shaft. Mass of the shaft is neglected for calculating torsional frequency. Mass moment of inertia of disk about axis of symmetry I is equal to m into bracket start do square plus di square bracket close upon 8, where do di are outer inlet diameter in meter, m is the mass of disk in kg. Polar moment of inertia of shaft J is equal to pi into bracket start do to the power 4 minus di to the power 4 bracket close upon 32, where do di is outer inner shaft diameter in meter. Using a standard formula of torsion, we can calculate torsion stiffness K is equal to Gj by L, where L is the length of shaft, G is the shear modulus of rigidity, which has a relationship with Young modulus of elasticity and Poisson ratio. Shaft length of same diameter. Suppose there are two discs 1 and 2, which is connected with the shaft, but diameter of shaft is same. So you can use a standard formula for torsion natural frequency omega is equal to a square root of complete square root of k into bracket start I1 plus I2 bracket close upon I1 into I2, where I1 is a I1 is a mass moment of inertia of disk 1 and I2 is a mass moment of inertia of disk 2, and K is the shaft stiffness. In case of Hertz, F is equal to omega upon 2 pi. So using this formula, we can calculate the torsional frequency. Now the shaft length of different diameters. Suppose disk 1 and disk 2 are connected, having shaft diameter are having different. In case we need to find the shaft stiffness of all the sections K1, K2, K3, and effective torsion stiffness is calculated using K is equal to 1 upon bracket start 1 upon K1 plus 1 upon K2 plus 1 upon K3, depending upon how many sections are of different diameter. And then you can use the torsion stiffness formula omega is equal to a square root of K into bracket start I1 plus I2 bracket close upon I1 into I2, which is in radian per second. In case of Hertz, F is equal to omega upon 2 pi. So we understood how we can use a standard formula for calculating torsion frequency of shaft having two discs, and how effective a stiffness shaft is calculated if the different diameters are available between the disc, and how different mass moment of inertia is used. Disk 1 you have to calculate mass of moment of inertia, similarly for disk 2, and use this standard formulas for calculate the frequency of the shaft. So hope you like this. Thank you for watching.